Hello to all. So welcome back to a magic tutorials for chemistry. So here I am starting with the organic chemistry, a topic of it. So we'll just start with the haloalkanes and haloalkenes. Correct. What do the words mean here? Halo means halogens. Alkanes, that is a single bond, carbon to carbon, a single bond. Again, halo means halogens. Alkenes, that means carbon to carbon, double bond. Correct? So we'll see the classification of these compounds first of all. So we have two types over here. One is aliphatic. Correct? One is aliphatic and the other one is aromatic. Aliphatic and aromatic. So aliphatic means what? The carbon atoms, they are linked and they form a single bond, double bond or a triple bond. Correct? They can be open compounds, open chain compounds. They can be branched also. Correct? So aliphatic, I'll write it as open chain compounds. They can be branched also. And between carbon there can be a single bond, double bond and a triple bond also. That is aliphatic. And the main difference between these two is what? Aliphatic means benzene ring is absent. Benzene ring is absent. Fine. Now aromatic means what? Again, it will be consisting of a benzene ring. Benzene ring compounds. Benzene ring is present. Or we can say benzene ring compounds. The compounds which will have a benzene ring. And these compounds, why the name is given as aromatic? Aroma means what? Smell. Correct? These benzene compounds, they have a pleasant smell. They have a pleasant smell and because of this reason they are called as aromatic compounds. Aliphatic, they are of different types. We'll check that first. The first one is haloalkane. Second one, haloalkene. And the third one, haloalkyne. Correct? Alkane, alkene, alkyne. Halo, halo, halo. Any halogen can be attached. Further, haloalkane means what? You write any one alkane. Methane, ethane, propane, butane. Correct? Any alkane. I'll write here simple alkane, that is ethane. C2H6. Ethane. 2 carbons, so ethane. Right? C2H6. Now H6 is there. One of the hydrogen, it is substituted by any halogen. It can be fluorine, chlorine, bromine, iodine. Fine. So one of the hydrogen substituted by one of the halogen. I'll write it as X because halogens we denote it as capital X. Correct? So one of the halogen is substituted. So this can be called as a monoderivative. It can be called as a monoderivative. Correct? Why monoderivative? Because only one halogen is present in the compound. So mono. Okay. I'll just take this. We'll write it afterwards. First let me explain the examples here. Fine. Now, again the same example I'll take. Fine. Ethane I have taken. Now, I will substitute 2 hydrogen with the 2 halogens. So, I'll remove any 2 of the hydrogen, this hydrogen and this hydrogen. And I'll write here X and X. The halogens can be same. Correct? Both are the same halogens. So, what is this now? Dihaloderivative. Dihaloderivative. Why di word? 2. So it is di, and what is the derivative? Halogen is substituted. It is dihaloderivative. Fine. Now, suppose 3 halogens are substituted. 3 hydrogens are substituted by halogens, then it will be trihaloderivative. Tetrahaloderivative. Correct? Okay. Shall we check some examples for this now? Easy, but still we will check some examples and try to write the name of these compounds. So again I will take another example. Here I have taken ethane. I will write for propane. Prop means 3 carbon atoms, right? Prop means 3 carbon atoms. Between carbon atoms there will be a single bond. Why? Because it is alkane. Okay. Satisfy the valency of each carbon with hydrogen. Correct. For this carbon also hydrogen, hydrogen, hydrogen. So this is what? Propane. Fine. Now one of the hydrogen I will substitute it with chlorine, Cl. Now what is the name of this compound? So wherever the functional group is attached, halogen, it's a functional group. Where it is attached to the carbon, that carbon will get number 1. Fine. Where is the halogen attached? To this carbon, correct? So that carbon will get number 1. Next will be number 2. Third carbon will be number 3. Fine. Okay. So how will I write the name now? 1-chloro. Because chlorine is attached, it will be 1-chloro. And what is the name? How many carbon atoms? 3. So it is 1-chloropropane. Correct? Why 1-chloro? Because chlorine is attached to the first carbon. So it is 1-chloropropane. Let's take another example. Now I will put 4 carbons. So it is butane. Right? It is butane. So 4 carbons. Single bonds because it is alkane. 1, 2, 3, 1, 2, 1, 2, 1, 2. I am not writing H. It is understood. We are writing. Okay. Now how many halogens? 2 halogens I will attach. So 1 over here, 1 over here. Fine. Now how to name this compound? Where is the functional group attached? Chlorine is the functional group. It is attached to the first carbon. So that carbon will get number 1. 1, 2, 3, 4. Correct? Now name the compound. So 1, 1. Why I have written 1, 1? Because 2 chlorine is attached. At which carbon? Both are attached to first carbon. Right. So 1, 1. How many chlorine are there? 2. So 1, 1. Dichloro. Put a hyphen, small dash. 1, 1 dash dichloro. How many carbon? 4. And all single bond, so it is dichlorobutane. Fine. Now you will have a doubt here. Suppose if I place this Cl at the second position, correct, instead of first position, what will be the name now? Same name will be same. The position will change, right? It is attached to carbon 1 and carbon 2. So I will write it as 1, 2. How many chlorine in the entire compound? 2. So dichloro. Total carbon atoms 4. All single. Butane. Correct? So we have completed with one part, that is haloalkane. Now we will check it in the haloalkenes, where there is a double bond between the carbon atoms. Fine. Now I am writing one example directly over here. So that is I'll take one example of haloalkene. So ethene, double bond. So ethene means C to C double bond, 2 carbons will be present, ethene. Satisfy the valency of each carbon, 1 and 2, 3, 4. Carbon should make how many bonds? 4 bonds, right? Okay, ethene. Now one of the hydrogen I will substitute it by any one of the halogen, Br I will put, bromine. Okay, what will be the name of this compound now? Ethene it is, right? Where is the functional group attached to this carbon? So I will mark this carbon as 1 and this will be 2. Correct? How will you name this? 1-bromo-ethene. Fine. So this way you can write the names 1-bromo-ethene. So haloalkane, haloalkenes means what? One of the hydrogen it is substituted by any of the halogens and you have to write the name. Okay, third we will see. This was second one and third one, that is haloalkines. Alkyne means a triple bond, correct? So I will take the example of ethyne. So C to C a triple bond will be there. Eth means 2 carbons. Satisfy the valency of each carbon, correct? Now we are learning halo chapter. So one of the hydrogen you will substitute by one halogen, any one hydrogen. So I will put here chlorine. So what it is now? Chlorine it is attached to which carbon? That carbon will get number 1 and 2. So 1 chloro, because chlorine is attached to first carbon, number 1 chloro, and what it is? Ethine. Eth because 2 carbon. Why ene? Why? Because there is a triple bond. Correct? Hope it is easy for you. Yeah, one more word I will just tell you. Haloalkenes, they can also be called as alkenyl halides. Alkenes can also be called as alkenyl halides. And haloalkynes can also be called as alkynyl halides. Fine. Just the spelling over here you have to check, that is here E, here Y. Alkene, alkenyl, alkyne, alkynyl. Correct. Just that E and Y. You have to see to it. Maybe 1 mark questions can be asked as MCQs. So let's check the next one. Dihalogen derivatives. Dihalogen means 2 halogens and both the halogen will be same. Correct. Dichloro, dibromo. Correct. So it will be same, and here we have 3 types, that is gem dihalide, Wick dihalide, alpha omega dihalide. Alpha and omega like W. Fine. So gem means what? Now how many halogens are there? Di means 2. So both the halogens, I will write it as X because I told you we denote halogens as capital X. So 2 halogens on same carbon, that is gem. Okay, gem, 2, 2. Wick means what? Vicinity, adjacent. So 2 halogen on adjacent carbon. Wick means what? Vicinity, adjacent, correct. Alpha and omega means what? Now think, what is the option left now? Both are on the same carbon, both are near to near. Now what is left? Alpha, omega, last. So both the halogens, they are present on terminal carbons. Terminal carbon. Correct? Shall we check some examples for this? So, gem dihalide means two halogens on the same carbon. So, I will write the example. Propane, hydrogen, hydrogen. Here I will put it as Cl, Cl, hydrogen. Correct? So, you can see here both the halogens, here just I have taken chlorine as the example. Both chlorine, where they are present on the same carbon. They are attached to same carbon. So, that is gem. Wick, adjacent, nearby, neighbors. So, carbon, 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 carbon. Okay. So, where is the halogen present? This carbon and this carbon. Both the carbons, they are adjacent, neighbors. Correct? They both are neighbors. Vicinity, adjacent. So, both the halogens, same halogens, they are present on the adjacent carbon. Rest everywhere you can put hydrogen. Let's check the next one, alpha, omega. So, 2x, two halogens present on the terminal carbons. 1, 2, 3, 4, 5. Okay, I am taking the example. Everywhere hydrogen, 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 hydrogen. Suppose two of the hydrogen at the terminal carbon, Cl. Correct? You can see two halogens I have taken. Both are same halogens and they are present on the terminal position. Terminal carbons. So, one will be alpha, one will be omega. Correct? The position anyway you can write, one will be alpha. This can be alpha, this can be omega, this can be alpha, this can be omega, up to you. But terminal, last carbon. So, hope you understood this. What is the difference in gem, wick, alpha, omega? Wick, vicinity, adjacent. Gem, both on the same carbon, and alpha, omega, terminal. Correct? So, you can remember. More examples you can write. I have given the example with chlorine. More examples you can write by your own. So, hope it is clear to you. We will move further. Just make a note of this emphatic topic, correct, of halogens and all. Let's move to the next one, that is aromatic. So, aromatic means what? Organic compounds with a pleasant smell, right? And they will have one benzene ring. Benzene ring is there means it is an aromatic compound. Okay. So, aromatic, the first one is nuclear halogen compounds. Nuclear halogen compounds. And the second one is side chain halogen compounds. Side chain halogen compounds. So, what do you mean by this nuclear and side chain? Nuclear means single. Side chain means the side chain is going on. To the benzene ring, it is attached, but still the side chain is going on. Okay, we will see the examples, you will understand clearly. Nuclear means only one halogen, single, one halogen is present. Where it will be present? In the benzene ring. So, benzene ring, hope you know to draw the benzene ring, alternate double bonds, hexagon, correct? I will put here Cl. What it is? Chlorobenzene. Correct. Nuclear halogen it is. What type? Nuclear halogen, because only one chlorine is there. Okay. One more example. Again the benzene ring will be there because we are learning for aromatic compounds having alternate double bond. Here I will put one group CH3. Here I will put one group Br. What is CH3 you leave? Okay. What is Br? Halogen, correct. Again now in this compound, how many halogens are there? One single nuclear halogen. So, if in the benzene ring aromatic compounds, one halogen is present, That means it is a nuclear halogen compound. Hope it is clear. Okay. Now let's move to the side chain. So again we are learning for aromatic. So benzene ring with alternate double bonds. Correct. The first one is CH2 Cl. CH2 Cl. And this chlorine. Correct. The side chain derivative means it will go on. Correct. CH2Cl, side chain derivative. That means where is CH? In the side chain it is to the benzene ring. See, in this examples, to the benzene ring directly the halogen is attached. Correct. But you can see over here, is the halogen chlorine directly attached to the benzene ring? No. Where it is attached? It is attached to carbon. Benzene ring, it is attached to CH2 group. And that carbon, it is attached to Cl. Correct? Here nuclear halogen means single one halogen attached directly to the benzene ring. But here indirectly attached to the benzene ring, that means it is in the side chain. It is in the side. Correct. So to the benzene ring carbon is attached and to that carbon Cl is attached. That means it is in one side. So side chain derivatives or side chain halogen compounds. One more example. Same type of example. So I'll write here CH2 CH2 Br. Correct. Is Br directly attached to the ring? No. It is attached to the carbon which is attached to the ring. Correct. So here nuclear halogen, one halogen, single halogen directly attached to the benzene ring. Side chain means one halogen. Correct. It is also one halogen is there. But where it is attached? It is not attached directly to the benzene ring. Indirectly attached to the benzene ring. So that is the difference between these two. Hope it is clear to you. Just make a note of it.